Hi, my name is Kate Schutz, and today I'll be presenting the results of my experiment for Lab 3. So today I'll talk about a little bit about the purpose and method of my experiment, then I'll talk about the observations and calculations, my code, and finally my conclusion and results. So the purpose of this lab is to compare the measured magnetic fields of a bar magnet to the calculated magnetic fields of a bar magnet through a code I will write. I use two principles, 4 different equations. I use the distance dependence equation in 2 different forms, and then the general Biot-Savart law, and the Biot-Savart law for a magnet on, or a dipole on the axis, and the Biot-Savart law for a dipole perpendicular to the axis. So a little bit about my method is first I downloaded an app that allowed me to find the distance dependence of a magnet and the magnetic field of a magnet. Then I found the locations of the magnet meter chip on my phone, and then I measured the distance between the magnet and the magnet chip in my phone at 5 different magnetic field magnitudes at 20 microteslas, 70, 120, 170, and 220 microteslas. Using this information and the equations I said previously, I calculated the magnetic moment of my magnet, and then lastly, I measured the off-axis magnetic field at several different points and recorded the x and z components of the magnetic field at that location. So some of the observations I have is that first, when the magnet meter chip was far away from the magnet, it measured a near zero magnetic field in the x direction, and as the magnet meter moved closer to the magnet, the measured x component of the magnetic field increased significantly. So here are some of my observations for this experiment, and the next thing I did was I put all my observations in an Excel sheet and calculated the average distance from the magnets at a certain magnetic field. So you can see at like 20 microteslas, which is what R20 means, the average R, which is the average distance, was 1.3 times 10 to the negative 1, and I have the average magnetic field, and then I have the natural log of R and the natural log of the magnetic field, which I put into a graph. So on the x-axis you can see the natural log of R, and then on the y-axis you can see the natural log of the magnetic field, and it gives you this equation y that you can see right here. And using this equation that I got from the graph, I can calculate the magnetic moment of my magnet. So using the distance dependence equation, the second form that I showed you earlier, I can tell that the slope is equal to n, which is negative 2.191, and the y-intercept is equal to negative 15.1, which is equal to the natural log of k. And so if I set these two values, or these two equations equal to each other, I can solve for mu, which is the magnetic moment of my magnet, and I found that it equals 1.357. So, like I said, I measured the off-axis magnetic field and recorded the x and z components at a certain location, and that's basically all you need to know. I wrote down my observations here, and I created a code. So here I'm defining a few variables, I'm creating a magnet at the origin, and I'm creating a function that can calculate the magnetic field. And then here you can see I'm defining a few variables. I'm defining the distance, which is actually the distance from, let's see, it's going to be the distance from the magnet on the axis to the magnet chip, and I have 6 different observation points here, 2 of them on axis, 4 of them off axis, and then you can see on lines 68 through 76 and lines 82 through 100, I'm making arrows that represent the magnetic field at the data points. Then I find the off-axis magnetic field, and I do this by finding d. d is the distance from the magnet meter chip to the magnet, and then again I create 8 different observation locations, and I create 8 different arrows that represent the magnetic field at the observation locations over here. So here is my results. And some of my results are that I want to compare the observed magnetic field and the calculated magnetic field that I calculated. So here are these being compared in this graph. I think they're pretty accurate given experimental, error. And same thing here for the these are the on-axis values and these are the off-axis values. So compare the average of the observed values and my calculated values, and they're pretty similar. And then overall, in experiment, I calculated the magnetic field, and I found the observed magnetic field, and I compared the two. A couple what if questions that I have to answer is what if, when I did my experiment setup, so the first what if question is that in the experiment, I actually oriented my setup so as to compensate for magnetic north. What if I hadn't done that and instead laid out your meter some state? What if I hadn't done that? What would have happened? What would have happened is a certain value would have been added to the different components of each of my calculations of the magnetic field. It'd be like a set plus, blank value to each of my calculations of the magnetic field. And then what if I had two identical magnets, and instead of using a single magnet, I used two? What would happen is all my magnitudes would double, and my arrows would double. Thank you.